Good evening, everyone. This is Dr. Belga Berg, faculty member at Department of CSE, AI and ML and Cybersecurity, Jane deemed to be University. Welcome to this session of Industry Connect. Our guest speaker today is Mr. Samir Vittala, Senior Manager in DevOps at Oracle India Private Limited. Mr. Samir has over 21 years of industry experience in fields like manufacturing and IT. He is a graduate in mechanical engineering from Osmania University and a certified project management specialist. He has completed associate management program in business analytics from Indian School of Business. Being an avid technology enthusiast, Samir's areas of interest are artificial intelligence and cloud technologies. Today, he would be talking on the topic supervised machine learning algorithms, K nearest neighbor. We are glad to have you here with us, Mr. Samir. Welcome to Jane deemed to be University. Please take over the session now.
Thank you, Mrs. Belga. Thanks for the introduction. First of all, I would really thank Jane Institute for conducting such an industry interaction to the students. What many colleges miss is that industry connect to understand what is happening at the industry. And this is really great for the students. And again, thank you for providing me this opportunity to share whatever little I could learn, grasp, as I studied at ISB and also as I experienced through my practical experience. So is it okay if the session is a bit more interactive? I do not like monotonous sessions. Is that fine?
Yes, sir. We prefer that actually.
Excellent. Thank you very much. Machine learning has become more of a coined word where people use left, right, center. But not many people have understanding of what machine learning is. I'm not talking about the algorithms and all. There is so much in the YouTube, in the internet. You have many things, but not many people understand that. So I know that most of your students have got exposure. I would like to understand what you know about machine learning. Your college is spending time. You're spending 1 hour. So the first thing I would like to understand, let me just briefly explain the agenda, why this session is more important. If you do not know why, there is no point in sitting here and spending 1 hour. Getting the fundamentals right. Of course, understanding what supervised machine learning is. I'll share an intuitive example so that you can connect easily with what KNN is all about. An overview of the nearest neighbor classifier and certain parameters and hyperparameters related to the nearest neighbor classifier. Controlling the complexity of the model. Pros and cons, a quick demo, and a recap, followed by a question and answers. So let's understand why we are doing what we are doing. I think many people know this, right? They say, I have a gut feeling. The feeling is coming from the gut. Gut is located in the stomach. Is it right to take decision based on gut? Guys, please be open and share your thoughts. You can put it in the chat. Is it okay to take decisions based on gut? No. Okay. At least my 2 nearest neighbors said no. So going by that, why not? Why not? Let me explain, give a small example. There is someone whom you know who probably worked with your family some time ago, and he's in a drunk state, comes to you and says, I need money because I need to use this money to get some tests done for my wife. Do you believe it? Typically, how does human mind think? Somebody who is fully drunk comes home and asks you for money, gives you some reason, will you really give money? What exactly the thought process goes into your mind? You look into your previous experiences, right? As someone who is drunk, unlikely that whatever he's saying is true, right? Probably he wanted to borrow money to drink more and all that. So you would not believe it. So what do you rely on? It's intuitive that we as human beings rely on data because we think, right? So going by decisions purely by gut, forget about organizations, insights, and all that. Just taking decisions based on gut will take us to do. Keep this in mind. Just keep this thought. Then how should we take decisions? We use data. Intuitively, we use data we might not know. Right from the time we have been aware of this world, we have been taught to recognize animals, to recognize alphabets, to recognize numbers, to wherever we are today in graduation, undergrad, whatever. We have been trained to use our brain. We use data. That is innate in us. That's a beautiful power of mind. The biggest neural network is sitting very much in our head. That's the brain. And we take decisions based on data. So why you're learning this? Because everywhere in the world, the key differentiator, the key USP between one organization and another, one potential employee and another, one potential employer and another, is the ability to take decisions based on data. That is why you are sitting here. This is how industry works. This is how businesses work. And the more you get in terms with this, the easier it is for your career down the line. So what is intelligence? Open question, please. What is intelligence? What do you think is intelligence? Any thoughts? You might be hearing, oh, this guy is very intelligent. He's pretty smart. He does very well in the class. What is so special about his intelligence? What is that attribute? Go ahead. There's nothing, no right or wrong, guys. Please participate. Okay, that's nice. Knowledge. If someone has a lot of knowledge, is it enough to say, qualified to say he's really intelligent? Being precise. Okay, nice. Being precise. Anything else? High intelligent quotient. So intelligent quotient is made up of intelligence. So what is intelligence? IQ measures it. It's a quantified number to measure intelligence, but need not be true. There is EQ also that is very important. But anyways, but good attempt. I really like that. So intelligence is the ability to learn from experience, solve problems, and use knowledge to adapt to new situations. So why that guy is so intelligent? He was able to quickly learn from experience, not necessarily from his experience. Right? A wise man learns from others' experience. You have seen a person who is ahead of you has stepped into a small pothole and injured himself. Would you go through that route? No. That's intuitive, right? Mind will try to avoid it. So the ability to learn from experience and use that knowledge, very key here, the last word, to adapt to new situations. That is what makes someone very intelligent. The adaptability to new situations. So it's not always necessary that what you face in life is a Control-C, Control-V of your experience in the past. There are flavors, there are variations, but still your mind is trained, it's built in such a way that it can still connect the dots and take decisions. Beautiful mind again. What's learning? Yeah, you can directly message me, no worries. Go ahead, please put it in the chat. Put it in the chat. And I would request you to use for everyone so that everyone sees that. There's no right or wrong, guys. The only wrong question is the question that is not asked. The only wrong answer is the answer that is not attempted. Go ahead, please. What is learning? You're learning, right? You're all students. You should know what is learning. What are you learning, by the way? Okay, let me give you some What's so learning itself is ability to gain knowledge from experience. The learner's keyword is here, but still I would say gain knowledge from experience, solve problems, and use that knowledge to adapt to new situations. Again, learning, it's all about experience, solve problems, use that knowledge to new situations. Experience, training, new situations, test. So I'm trying to help you connect to those things which we use. Let's talk about features. Sorry to use German Shepherd. I really love German Shepherd. So I've used this example. So imagine you're a kid who's never seen a dog in their life. You just went to your pre-primary school. How would you look at it? What would you make of this picture? Be very naive. Imagine you're just fresh in your mind. Definitely you would say this is not something like my mom and dad because it is different, right? So it's a different thing. Then you start learning. How do you learn really? It has long ears, something different in the eyes. Probably the kid might not even know what ears are, but there's something which is long, which is protruding, right? And he tries to compare with his ears. It has a nose, which is projected, color of the skin, and legs. It doesn't have hands, right? Tail. So what are essentially, you say, he has very good features. He has features similar to his aunt. People do use it, right? So features are nothing but attributes pertaining to a category, brackets class, because I don't want to really overwhelm you with jargon. Let's be very simple, commonsensical, intuitive. Attributes pertaining to a category. The category could be a dog, or within dog, if I'm talking about breeds of dogs, of an example. This is one example. This is the only dog I'm seeing for the first time. So this is an example for me. And there are certain attributes I'm associating with this particular example, which is nothing but my data point. So far, so good. Any questions? I'm just watching if anybody is raising hand. Any questions? Please go ahead and put it in the chat. Because getting your fundamentals right is very, very important. And do not complicate yourself with too much of jargon. Try to learn intuitively. So how do we categorize? Now, in the previous slide, I've seen a dog, which is a German Shepherd dog. It's okay. Fine. Let's assume that I don't know a German Shepherd dog. I've seen a dog. There are certain features. Based on this example, one single example, I'm seeing another dog. So intuitively, what does the mind do? I've seen that picture maybe 2 days ago, 3 days ago, or a minute ago. Come on, even this dog, it is fat. That dog was lean. This dog is standing. That dog was sitting. Still, our mind is sharp enough to draw those parallels. Is the mind really looking at how fat or thin it is? Again, it is looking at those key features. So we learn the attributes of a particular category. The attributes are features. Category is the class. And next time we see a new example, which is the test data, we compare the attributes of the new example with the one we have already learned, and then decide if the new example belongs to the same category or not. Is that not classification? Is that not intuitively we do day in and day out? Is that not how mind works? A guy who is tall, who's fair, who's handsome, he's answering in the class, he must be very intelligent. Because that's what we have learned previously. Forget about handsome and all. A person who's always sitting in the first bench, always willing to raise hands, always asking questions. What does it talk about him? He's very curious. How do we know that he is curious? He can fake it, right? Based on our experience as we went past our primary, middle school, high school, college, etc. So we are learning the attributes intuitively and then comparing with a new category, with a new example, and trying to assess if that example belongs to the same category or not. So I'm only using the words, terms here and there so that you can compare them and understand what it means. In machine learning, we say features. Features are attributes, class, category. And you are learning. You are learning. Any questions so far? So I learned the attributes of a category. That's in my mind, recorded somewhere, sitting somewhere. There's a pointer to that memory location. And next time I see a new example, my mind fetches that something which I've already learned, those attributes, and compare and say, does this belong to the same category or not? Let's talk about generalization. Previously, we were talking about only German Shepherd. Imagine I've seen in my life only German Shepherd dogs. And a new example comes up. Now I have this. Would I say this is a goat? Would I say this is more like a sheep? My mind would still say, though they are different, possibly all belong to the same category, the main category, which is a dog. That is generalization. Mind generalizes. We have the ability to predict or assign a label to a new observation based on the model built from past experience. I'm using the word model, but that is already in your mind. Without knowing, your mind, your brain is building models. And that model is used to quickly determine what anything about a new example that is coming. Where does it belong to? I'll not really go into the details of neurons, synapses, and all that. But that innate thing is in your mind. So that is generalization. It is very, very, very important. I'm just re-emphasizing these things which I've told before. Please register these things in your mind very well. Intelligence, learning, features, categorizing based on the features learned, generalization. This is what mind does. Nothing out of the blue. Any questions so far? Okay, you are engineering students. I don't know how many of you have learned linear programming. Have you heard the term optimization? Please, I want this session to be as participative as possible, so that I get excited when people are very interactive. Please go ahead. Even people who have not learned linear programming, we still know the word optimize. Please optimize yourself. How do I optimize the fuel efficiency of my bike? We use the term, right? Are you familiar with optimization? Okay. You have heard these terms: maximize, minimize. Would you want to minimize your earnings or maximize your earnings? This is intuitive, right? Please go ahead and put it in chat. You want to minimize your earnings or maximize your earnings?
Maximize.
Yeah, that's intuitive. Thank you. And you want to maximize your learnings from this session or minimize your learnings?
Maximize.
And what do you want to do in terms of your time utilization? Maximize it. What about distractions as you attend this session? You want to minimize. Excellent. That's great. So you understand it. I know maybe not all have participated, but you do understand that optimization is all about maximizing or minimizing something. What that attribute is different. If I'm planning my shift production in my plant, I'm sorry to use it because I've come from manufacturing, or maybe if I'm planning my shift in a BPO, I want to maximize my productivity, at the same time minimize the cost incurred. We keep doing, that's what the brain does regularly, right? So I'll try to give a bit more deeper decision technically. Is the process of determining the decision variables. Decision variables is how many students per batch, how many students per shift, how many workers per shift, how many machines per shift. So the process of determining the decision variables by maximizing or minimizing the objective function. What is my objective function? It could be cost. I want to minimize my cost. If it is revenue, I want to maximize my revenue. Subject to constraints. If my goal is to increase the production, can I keep on adding labor? Common sense, can I keep on adding labor? Is it okay? My boss says, I need to produce so many, increase your production. I'll just keep on hiring people. That's easy, right?
No.
Is it good enough? No. There are some constraints. My boss says, your budget should not exceed this. That's a constraint. So I'm always doing optimization. Mind is good at doing that. I determine my decision variables by maximizing or minimizing the objective function subject to constraints. Right? So keep this in mind. Keep this thought in your mind. The people talk a lot about machine learning, but they forget the fundamentals. So let's talk about supervised machine learning, because that is what we are dealing with. But before machine learning, what is machine learning? Any participants, please, can you please try defining what is machine learning? What is happening when machine is learning? But if I use the word random forest, CNN, RNN, people will raise hands. I know this, I know this. Potentially, because you are in AI field. But if I ask you to define in the most layman terms, what is machine learning? Clue? Clue lies in the previous slide. Any participation, any thoughts? Please, you want to speak, you can speak. This is for your own benefit. The organization is spending time and money. Go ahead.
Sir, maybe analyzing and generalizing data and making to some logical thing.
Analyzing, generalizing, can't I do that in a report? If I just, in Excel, I just get the data, build some reports around it. Can't I analyze based on the data? Can't I derive logical conclusions? Why only machine learning? Good attempt. Good attempt. Go ahead.
Sir, to make a machine understand what we want to do.
And how is the machine understanding?
Through their language.
Language? Is that machine learning?
Sir, by the past data.
Okay. So what by past data?
Basically, we upload the past data and the machine gets to know like all this. If this comes, this might happen. So that's past data. Basically, we have to upload like if these kind of things is happening, like the result should be like this.
How
so basically, we are making sir.
Good attempt. But how is it learning? What is the process of learning? What is the process in which machines are learning? Good attempt. What is the process in which machines are learning?
Sir, I have no idea on that.
No worries. Good attempt. Good attempt. You've tried something. Yes, you're talking about data. You're talking about analysis. You're talking about logical decisions. Very good. Very good. Good attempt. Very good attempt. As I said, the key is in the previous slide. Every machine learning algorithm is an optimization problem. Every machine learning algorithm is an optimization problem. I have an objective function, which is a cost function. And I have decision variables, which are my weights, subject to constraints, which are my boundaries. That's why the previous slide is very, very important. If somebody talks about machine learning without talking about optimization, he's wasting time, or he's not explaining you properly what machine learning is. Every machine learning problem is an optimization problem. What is being learned is the weights of each feature of a class based on examples. And what is the goal? In terms of classification, if I'm talking about supervised machine learning classification, my goal is maximum class separation. And within the class, my variance has to be minimum. Let me give a small example. You're grouping your class based on heights. And I'll give you two options: people who are tall, people who are not tall. So how do? You just ask people to stand next to each other, then keep on who is not matching with the taller group, you start pushing here and there. In the process, what are you doing? You're creating a boundary between the two classes. You're creating a boundary. And how you want the boundary to be? As far as possible. You're maximizing the class separability. And within a group, within the tall people, can you accept somebody who is very short to be in the tall people? No. So I'm minimizing the within class variance. And my cost function, typically what people use is cross entropy loss. Don't worry too much about it. It's an objective function. I want to minimize that cost. My difference between my actual distribution and predicted distribution, I want it to be minimal. And once my model is finalized and has the optimized weights, its efficacy is based on how well it can generalize on real world data. So once my model is finalized and has the optimized weights, what is it learning? It is learning the weights, which is nothing but my decision variables. What is the weight it has to assign for each feature for a specific category or a class? And how do I measure its efficacy? How well it can generalize on real world data, which is test data. So remember, machine learning is an optimization problem. Objective function could be different. The approach to maximize or minimize whatever is that objective function typically cost, you want to minimize the cost, might be different. You might be using gradient descent or some other methods. But bottom line is, it is an optimization problem. And what you're learning, the machine is learning the weights. Go back to the dog example. Long ears, projected up, German Shepherd. 4 legs, no hands, has to be an animal. Tail, which is twisted or wagging, has to be a dog. Probably if I have one more attribute, it barks or not, a Boolean, anything that barks is a dog. By and large, it can be a wolf, etc. But typically, so this is how your mind is doing. Mind is learning. That is what we are training machines to learn. Machines are learning the weights that they can assign to each feature of a particular class. Eyes, features. Tail, features. Legs, number of legs, features. Tongue, tooth, anything, teeth, anything. These are all features. And it is assigning a weight for each of these features and saying AX plus BY plus CZ plus some bias is equal to class 1. And A1X plus B1Y plus C1Z plus some other bias is equal to class 2. And what is it determining? The weights, ABC, A1, B1, C1. So every machine learning is an optimization problem where I am minimizing or maximizing my objective function. Typically, if it's cost, I want to minimize my cost function, subject to constraints. And I'm learning the weights. What is being learned is weights. Please register in your mind if you are interested in continuing in AI. Okay, you are learning weights. It is an optimization problem. Okay, I'm just spending a lot of time here so that you get that concept very clear. Anything else is crap. If somebody talks about random forest, if they talk about Other ensemble models, they talk about GANs, RNN, CNN, doesn't matter. It's only a terminology. Understand it as an optimization problem, right? Right. Let's go into that supervised machine learning algorithm, which we're going to discuss today. With all that in your mind, just keep that in your mind. Don't worry, mind has a beautiful way of recollecting things. Now, this is a colony I might have borrowed from some construction company. Bear with me, it doesn't, I do not own it. I'm giving a question to you. Please guess what kind of a person is going to stay in this house without any data. Can you make a decision? Can you say here some sports person is using, some sports person is going to live here without any data? Can you just guess? Can you?
No.
No. You need some data, right? Without data, you can't guess anything. So you need some reference point from where you can deduce or conclude. Now, I say the neighbor of this guy is an actor. With this data, with this information, if I ask you, guess what could be this person? What would you say? Guys, please participate. What would you say? You'd say he's a sports person? This is intuition. There is nothing machine learning here. There is no model. I'm talking about common sense. What would you say? Given this data that the person next to him is an actor, what would you guess about this guy? The unknown guy. Intuitive, friends. Chat, please. Yeah, actor. That is what you do, right? It's intuitive. There is no machine learning here. I'm not teaching you any algorithms, any models till this point. Intuitive. He has to be an actor, very likely, based on the data which I have. Right? Someone rich enough to compete with an actor. Nice. Could be. Yeah. But based on this data, probably he's an actor. How do you know? So somebody might be taking this house on rent. It could be possible, right? Anyways, nice. So, yeah, fair enough. Same example. Now I'm giving you one more data point. Now, what will you say about this person? Confusion? It was a lot easier when there was only one data point given. More data, more confusion, right? So what would you guess? Come on, participate, chat. Nothing right or wrong. Go ahead. Go ahead, guys, please. I'm saying guys. Or all students, please participate. Businessman. Between actor and police, you would want a businessman. You feel he's a businessman. Okay, fine. Nothing right or wrong. No worries. Right. Director. Someone related to film industry. Makes sense. That's a decent assumption. But assuming I don't have any other class, I have only actor and police. Only two class problem. Binary classification problem. Public figure, if I know, yeah, that's fair enough. All your guesses are fine. But imagine I have a binary classification problem. I have only two classes, actor and police. Nobody else stays in this column. With that data, what would you say? Is the middle guy an actor or a police? Is it easy to take decision? No, right? No. He can be an actor, he can be a police. How do I know? The data is not enough for me to deduce or make a conclusion. Right? Now, will your perspective change? So I have two policemen one actor. Now slowly where your mind will weigh towards? Intuitively?
Please.
Very likely police. Because now I have two policemen, one actor. Now my data is changing my decisions. Just keep that thought rolling in your mind. Now, lot more is here, right? Very likely it's a policeman. Probably actor finds it very safe to stay between the houses of policemen because he'll be safe. Anyway, that's in a lighter vein. So this is exactly how your nearest neighbor algorithm works. So I did not even jump into code or anything. I'm just talking about intuitive examples using which we can easily correlate to what is exactly happening. Nothing is out of the world, guys. Everything is from our experience. So the nearest neighbor classifier first learns the available examples and attempts to classify the unknown example based on the nearest neighbors. How many nearest neighbors and all will come to it. So the nearest neighbor classifier, it's a supervised machine learning. Why supervised? Because I'm training it, right? How do you teach a small kid? Keep him in your lap and say, this is a cat, this is a dog. So you're training under supervision, right? That is how you're trying to teach the small kid, which is a machine, saying this is this class, this is this class. And after 10 or 20 examples, you say, come on, I'm bringing a new one. You tell me what is this, right? So in nearest neighbor classifier, I'm learning all my examples pertaining to different classes, not necessarily binary classification problem. It can be multiple classes and a multivariate data. So I'm trying to predict the class of this unknown example based on my nearest neighbor. With this, just go back to this example. Who is my nearest neighbor? If possibly, imagine this house is very far away. This guy is close. So if I say only go predict based on one nearest neighbor, I might predict actor. So I'm using the term far. Remember, distance. Okay, again, that is intuitive. So what is the metric to decide who is near, who is far? That would be the intuitive question, right? How do I decide this guy is near or this guy are near, right? Is my neighbor who is next to my house near, or the person who is exactly behind my backyard near to me, or my neighbor on my right side is near to me, or my neighbor who is exactly opposite to my house near to me? If I ask you this question, you'll say, okay, come on, give me a break. What is the basis on which I'm going to measure my similarity? That will determine, that is the key differentiator that will tell me who's near, who is far, right? So I need a metric. The metric is nothing but the distance. There are various distances. One distance is Manhattan distance. Manhattan distance is nothing but the absolute difference between, let's say there is a coordinate, it says x comma y, but typically if I say in a two coordinate axis, x1, y1 and x2, y2, then my distance is sum of x1 minus x2, absolute distance, absolute value, that is, it cannot be negative, plus y1 minus y2. If I have n dimensions, that is, if I say y is one class, one example, and x is another example, and I have n dimensions, x1, x2, x3, x4, x5, x6, x7, and I have y1, y2, y3, y4, so on till y7, then sigma sum of x1 minus x2 plus y minus y1 minus x1 minus y1 plus x2 minus y2 plus x3 minus y3 plus x4 minus y4 plus x5 minus y5 plus x6 minus y6, and so on. How many observations are there? So why I'm saying an n-dimensional plane? Eye, one dimension. Dog example, ears, one dimension. Tail, another feature, one more dimension. Legs, one more feature, one more dimension. Nose, one more dimension. So now if I have these coordinates, x1, x2, x3, x4, x5, so on till so on, whatever is that n. And likewise, for another point, I have y1, y2, y3, y4. Then the absolute distance between each of these coordinates sum up is, the sum of that is the distance. That is Manhattan distance. Any doubts here? The word Manhattan came because typically when you have the structured layout, you can't go from one house to another by jumping. You have to go take to the next lane and then take a left and right and so on and so forth. Don't worry too much. Remember, it's a distance measure. Okay, you need not do anything to calculate Manhattan distance. The program will do it for you. Then Euclidean distance. How many of you know Pythagoras theorem? Ah, good. Thank you. Guys, you're all math students. You should know Pythagoras theorem. Please raise your hands. How many of you know Pythagoras theorem? I would have expected 100% people to raise their hands here. It cannot happen that only a small percentage of class knows. Yeah, good, good. You know Pythagoras theorem. So Pythagoras theorem is sum of the square of the hypotenuse is equal to sum of the squares of the opposite of the adjacent sides, right? So if C is the hypotenuse, A and B are the adjacent sides, C square is equal to A square plus B square, C is equal to square root of A square plus B square. So the Euclidean distance is based on that. And only difference is there, it's an absolute difference between each of the dimensional coordinate. Here it's the sum of the squares and the square root of that. And typically where it is used, you know, you're talking about maybe flights where you do not have that left, right, center, you directly go between one point to another point. Typically we use the term displacement, people who are familiar with physics. So one classifier is one metric for distance is Manhattan distance, the other one is Euclidean distance. And there are other metrics like cosine distance and Mahalanobis distance. The famous, very famous statistician from Bengal, on his name, we have this distance function. So remember, distance means whatever is a measure you are using to find the similarity. Mind you, this is the most difficult part in k-nearest neighbors if you want to optimize it. And a lot of research is still going on to find the similarity function. Imagine if I'm comparing tastes, if I'm comparing flavors, if I'm comparing smell, how difficult it is to classify. Just keep that thought in your mind. Okay. So the similarity function is the key. So the key for k nearest neighbors is the distance function, because all along we are saying near, far, near, far. What is near, what is far? Defined based on my distance function. It is the key, right? If you want to do any research, publish a paper on k nearest neighbors, then definitely your most of the effort would be spent on this. You need not really worry about k. K is anyway the algorithm will whatever is the iteration you do for, it will iterate between what are the values of k you want. But the similarity and distance function is important. I have not yet come to k, but I just wanted to explain. Now let's say, come back to nearest neighbor. The same example. Now here we have pink and blue dots. Now this one, previously I don't know how to classify. If I have only one nearest neighbor, right? Only one nearest neighbor, this guy pink is very close. So I would classify this dot as pink. Okay, this is all my training data set. Okay, and this is my test data set I dropped. Now I realize this is very close to this pink dot, only one nearest neighbor. So I classify it as pink. Intuitive, right? Like the same example. Actor. The next guy is only actor. He has to be actor. Now what happens if two nearest neighbors? Same confusion we had. Remember that example. On one side I have police. On one side I have actor. Who has to be this guy? Confusion. You are confused. Machine will also get confused. Mark my words. The algorithm will get confused. So that is the reason why we set the k value to odd. Right? In Supreme Court and High Court, a bench of 5 judges, a bench of 3 judges. Normally, they don't use the even number of judges because imagine if equal number disagree and agree. Tough to make a decision. So that's why you have odd number. So typically, k value which set be set to a odd number. How many? K is nothing but how many? How many neighbors? 3 nearest neighbors. Now, 2 of these guys are blue. Though this guy might be closer, now it vote says that it is blue. Now it has got the distance, but once it gets the distance, this is one of the disadvantages. Once it computes the distance, finds the 3 nearest neighbors, once it does that, it forgets the distance. It says, I could care less. Now it's done. Now among these 3, what is the majority class? Majority class is category is blue, so it has to be blue. This is one disadvantage. Any questions so far? It's all intuitive logic. Go back to the same example. Actor, police. I have one more police example next to that guy. So there are 2 police and 1 actor. So very likely this guy has to be police. Intuitive logic. So once I know the distances, I will not worry about who's in the 2nd lane, 3rd lane, 4th lane. I would only worry about these 3 examples. Closest guys are these guys. Now I am not worried about distance. There are 2 policemen, 1 actor. So very likely this has to be policeman. Right or wrong, there is always pros and cons with the logic. But this is how it works. Understand how the algorithm works. So how do I control complexity in KNN? So what happens if your boundary or the class separation is very, very complex? Complex is, you can think of it as wiggly. All right? Wiggly is, you know the shape of amoeba? You might have learned in your classes, right? How the amoeba shape is, right? Imagine if your boundaries are like that. It's very, very complex. Such complex boundaries are very brittle to noise. Noise is outliers. So let me tell you, for you to understand what an outlier is. Let's say average height of your class is maybe 5 feet and 5 inches. I'm just telling, don't get offended if somebody is very tall. So imagine there is a new student who has joined. Till now, your average height was 5.5. Maybe your max height is about 5.9 or 6. And your average height is 5.5. Now a new student joins whose height is 6.5. Or the other way, a new student joins whose height is 4.5. Or maybe 5. So what will happen? Your average will be impacted. Not to that extent because there is only one student with that height. What would you call such a person? An outlier, right? You never make decisions for outliers. You'll try to accommodate them, but decisions are never taken based on outliers. But what happens is outliers create a problem. They make it very difficult for you to take a decision. Same example, police, actor, etc. Suddenly, in this entire colony, imagine everybody is policeman. Next to that unknown person, there is only one actor. Outlier. That will make your decision very difficult, right? So if your boundaries are very, very complex, it will be your model will be very brittle to noise. So you want your boundaries to be as smooth as possible. Don't worry too much. I'll explain with an example. See here, how are the boundaries between these colors, blue and pink? For k is equal to 3, see how the boundaries, you see here, very wiggly. Now imagine in such a complex boundary, by and large, this has to be blue, but now even let's say there is some point here. In such a complex boundary, some point at the borders might be classified as blue, though it is really pink because of such a complex boundary. So I said you're talking about when you're classifying their class into tall guys and not tall guys, you're drawing a boundary. And I want that boundary to be as smooth as possible, not wiggly. That's my goal of classification. Okay. Now what happens when k is equal to 5? Much better, right? K is equal to 7. K is equal to 9. Now you see the boundaries are becoming more and more smooth, right? Now it's easier. By and large, you can say, okay, by and large, I can have few outliers. Everybody in this has to be a blue dot. So everybody in this colony has to be a policeman. Everybody in this colony has to be an actor. So as k increases, the boundaries become more smooth and smooth. The complexity decreases. Now, this is counterintuitive. As k increases, complexity decreases. As k decreases, complexity increases. You want your model to be less complex. Any complex model is very susceptible and brittle to noise. Outliers. K is equal to 11, 13, 15, 17. Boundary is becoming smooth and smooth. That's very clear. All these things are blue, all these things are pink. There will be definitely impurity. No model is 100% accurate. If you really make a 100% accurate model, that means you're overfitting your data. And the last thing we want to do in machine learning models is overfitting, right? As I use the word, if you remember just few slides back, generalize. Generalize. I want my model to generalize. I don't want it to memorize. I want it to be intelligent. I don't want somebody to by heart mug up entire content and go to the school and reproduce. No, I want him to understand the content, and then when a new example, like new question is given, he'll be able to generalize. That is what is tested in competitive exams, right? Not a copy paste. So similarly, I want my model to generalize. I want my model to be intelligent. I don't want it to be dumb. I don't want it to memorize. Right? So as k increases, my boundaries are more smooth and my model can generalize more effectively. Okay. A few questions. Let me ask these questions. What is being learned? So far we said machine learning is learning some weights, right? Optimization problem, learning my decision variables, to maximize or minimize my objective function, subject to constraints. Machine learning is an optimization problem. So typically we learn weights. Now in case of k nearest neighbors, what is being learned? K is the number of neighbors. Sorry, Shreyans, I didn't see the chat. Let me answer a few questions. I'm sorry, I just closed the chat. Yeah, one question from Shreyans is, if we have to find distance, why we have too many different functions? We use only one function when we create a model. Shreyans, we use only one distance function. But maybe based on the situation, I might have to use a different similarity function or a distance function based on the nature of business problem. So if I'm talking about distances between neighborhoods, maybe Manhattan distance works better. But if I'm talking about distances traveled by flights, Euclidean distance works better. So based on the nature of the business problem, I select that distance function. Is that clear, Shreyans?
Yes, sir.
Thank you. Very good question, but really good question. Love it. What does k mean here? K is number of neighbors. Shreyans, again, k means the number of neighbors. K nearest neighbors and two neighbors. I'm making a decision based on two neighbors, two nearest neighbors. Okay. Clear, Shreyans?
Yes, sir. Clear.
Thank you. Sorry, I just closed the chat because I didn't want to miss my flow. So what is being learned? Questions? Shreyans, looks like you have understood well. What is being learned? What are we learning in k nearest neighbors?
We are learning here. It has been learned that learn for predicting which kind of person is being been in their locality by having the data that which person are already there.
Okay, okay, okay. But are you really learning anything? What are you doing at the time of training? When, okay, I'll put this way. When is the distance computation happening? During learning? During learning, am I computing the distance? Go back to the example. Actor. When I'm computing distance, when a test data set is there, or when I'm learning, when I'm given my examples? When am I using the distance parameter? During testing or training? Any items, please? When am I using the distance to calculate whether it's near or far? Let's go back to this example. I'm computing distance once my test data, my test point is here. I'm not computing distance prior to that. If there is no test data, what is there? Nothing. I'm just memorizing my data points. Understand this well, guys. If there is no test data, I'm not learning anything. So this is a bit counterintuitive. We call it machine learning, but it is not learning anything. So it is a non-parameterized supervised machine learning approach. Nothing is being learned during training. It is only memorizing the data. It's just saving this data into its repository in memory. That's all. Let x is equal to 5, y is equal to 3, z is equal to this, something else is that. It is just committing this into its memory. It is not learning anything. So please make it very clear. In KNN, nothing is being learned. It's a non-parameterized supervised machine learning model. So how is the training time then? You are not learning anything. So how is the training time? Is it high or low?
Low.
Low. It's very fast. It's just how better processor you have, it will just dump it into the memory. So training time is very, very low, very fast. But is that what you want? Keep that thought. What happens at scoring time? How is it scoring? So how is it validating that? At the time of testing, it is computing the distances. Let's say I have 10 examples. I want to find 2 nearest neighbors. Let's take Manhattan distance for that simplicity. So it is using Manhattan or even Euclidean distance, doesn't matter. With each of these 10 training examples, it will compute the distance of the 11th data point, which is the test data, sort it in ascending, and based on what is my k, it will say these are my 3 nearest neighbors. That is for 10 examples it is doing. What happens if I have 100 examples? Time will increase or decrease?
Time will increase.
Increase, right? So the time will linearly increase with my training data. So the scoring time is very, very poor, very poor. How many of you use Google search engine? Everybody, right? What if I were to use KNN for my Google search engine? Is it good enough? Very poor. So it's not just model accuracy, model complexity. I want a decent model which can generalize, but perform very quickly in real time. Now, this is where your business experience comes into play. Right? I want my model to be very fast. Thankfully, in an internet connected world, you learn all this through your examples. You can be at home and still understand. So scoring complexity is very high. So how should I choose K? Obviously, we have learned that if the K is very small, the K value is very small, it is brittle to noise. So I want K to be reasonably large. But very large K doesn't necessarily mean it's a very good model. Imagine I'm encompassing everybody and putting all actors and police into a single category class called actors. Is it correct? No. So too large a K is also not good. So this is where fine-tuning my parameters, hyperparameters. Sorry, it's not a parameter, it's a hyperparameter. There's no parameter in KNN for that matter. So I'm fine-tuning my hyperparameters to make my model better and better so that it can generalize better, it is less brittle to noise, and it can perform better at the time of scoring. So how brittle is this model? Brittle is what? Glass is brittle. Minor impact, it will break into pieces, right? You don't want a model which is brittle. Slightest noise also, it will be affected. So KNN is very brittle. So how do I reduce scoring time? A lot of research is going on these areas. One of them is k-dimensional trees, KD trees. So a lot of effort is going on in this direction. But just remember KNN, but it's not that extensively used in business case problems where scoring time is a criteria. But people are still doing research. Who knows? Something might come very good. So one more con is, as I said, it loses distance information. Once it finds the distance, finds k nearest neighbors, will it remember the distance? It will just throw away. I don't need it now. I have my 4 or 5 nearest neighbors. Now I'll decide based on what is the majority class and classify this test example. So that is one more con. Clear? Any questions?
No, sir.
Right. Thank you. And these problems are overcome using better classifiers. We call it kernel density functions. One of them is Parson window classifier. So this is not the purview of this session, but just for you to understand that there are better classifiers than KNN. So I'll try to give a quick demo. Now, demo is nothing so great about it. You have enough code in Git. There's nothing unique I'm doing. You have enough code in Git to, let me show. Sorry, let me share my entire screen on that. Oh, 1 minute, I think. Let me open. Accidentally, I closed my Jupyter window, but it's there. Don't worry. Just give me 1 minute. At the time of joining Zoom, it was creating some problem. And, it's loading 1 second. Ah, thank God, it's there. So just this is something you'll get everywhere here. I just took it from the internet. Nothing great about it, but let's understand what we have learned theoretically with this model. Okay, these are all the functions you're trying to import, the packages you're trying to import. K-neighbor classifier, test train split is a function procedure which can split your data into test and train and all that. Pandas is very important if you're working on data frames. And NumPy is for arrays. Matplotlib is for plotting. Okay. Now this iris data set is very, very famous. It classifies the kind of flower based on its feature. Okay, sepal length, sepal width, and whatnot. So this is how the iris data looks like. It's a NumPy array. You people are very famous with arrays. And what I've done is I just loaded this into a data frame so that converted into data frame so that you can easily visualize. It is already there. So this is how my iris data, which is data, not my targets. Targets are nothing but my class values. This is how my data looks like. These are my features: sepal length, sepal width, petal length, petal width, and it will say based on these parameters, it is this kind. based on 150 examples. Okay, I'm just printing the target data frame. This is how it looks like. Now, this is the class value. Okay, these are the class values. Some are zeros, some are twos. So let's understand what do these classes represent. So here it is. 0 is setosa, 1 is versicolor, and 2 is virginica. Don't ask me what it is. I'm not a botanist, so I don't know these things. But just understand that based on certain features, characteristics, attribute. Again, remember the German Shepherd dog. Certain attributes, ears, eyes, nose, blah, blah, blah. I'm determining a category. Category is nothing but a class. Okay. And then what I do is I load this data, then split. Now, all my data is in X and all my target is in Y. It's an array. You can work with data frames also, but arrays are much more easier to manage when you're doing machine learning. And then I'm splitting into train and test. Then I've got my accuracy. Then I'm plotting the accuracy. And you can see here, blue is the testing data accuracy. Orange is the training data accuracy. Seems to be very highly accurate. Then as K increases, you can see here, my test data accuracy is still flat, almost till K is equal to 6. And beyond K is equal to 6, my test data accuracy starts dropping severely. So possibly, I would want my model to be performing well on my test data. So I want a more generalized data. I could pick the model here, but will I pick here? No. Again, our concept, K is equal to 1, susceptible to noise. What if I have outliers? Is this model good enough? No. Though my training data accuracy is less, possibly I would pick something between K is equal to 5 and K is equal to 6. So this is where I optimize my K value and say probably this is better. Now there are a few catches here. Is it good enough if I just have one train data and I play with K is equal to 1, 2, 3, 4 on my train data and keep testing, iterating on my test data? Is it good? Is it good? Friends, is it good enough?
No, sir.
Why is it not good?
So because you are giving same data again and again.
Very close. I want my test data to be isolated here. I want my model to generalize. I don't want it to memorize. I want my model to generalize the examples. I don't want it to memorize. So what I do, I typically split my data into train, validation, and test. Probably something like 70, 20, 10%. So I train my data, optimize it, then validate on my validation data, which is 20%, play with the hyperparameters, K, distance, then get a good model, then see once how it is performing in my test data and say, this is my accuracy. This is the best accuracy. I don't iterate on my test data. If I iterate, I'm overfitting the model again. I don't want a model that overfits. Overfitting is nothing but memorizing. It's not generalizing. What is intelligent about an overfitted model? It's not learning anything. An overfitted model is not learning anything. It is only memorizing. Right? So I typically want to split my data into train, validation, and test, maybe 70, 20, 10 ratio. Right? There are a lot of other parameters you need to understand. I would like you to spend some time and understanding what happens. Let's say the same case, 3 classes of flowers, and 150 is my data set, and 100 examples belong to one class, 30 examples belong to other class, and only 20 examples belong to the third class. I'll bring one more example. Based on certain 6 or 7 parameters, I'm trying to decide if a particular tumor is cancerous or not. Is it malignant or not? Okay. Now I've gone through my entire data set. Typically, the occurrence of cancer is less. Yes. By and large, thankfully, now it is increasing, unfortunately, but typically it is less. So based on my examples, the number of people having cancer is far lesser than the number of people for whom the tumor was indeed malignant. So the number of people having cancer, my examples of people having cancer, my example of tumor properties which are malignant will be far lesser than the examples I have of benign tumors. In such a situation, I face what is known as class imbalance. So in order to reduce the class imbalance, I can't create people with cancer, right? So there are some methods to work with that class imbalance problem. I might use data imputation statistically. Again, people do use KNN for data imputation. I might I do sampling, oversampling and undersampling. I undersampling from a class which is high in number and oversample from a class which is low in number, so that I have a balance between the classes. Please keep that in mind, that though that is not in the purview, I'm explaining these points. The other aspect is very famous in machine learning called curse of dimensionality. Right? I know that is not in the purview. I'm explaining the curse of dimensionality. Just tell me, I have three variables X, Y, Z. You're all math students, right? I have to solve for X, Y, and Z. I'll give you two equations. 2x plus 3y plus 4z is equal to 10. And 3x plus 5y plus 15z is equal to 20. Can you solve it?
No.
No. Because my math knowledge says my number of equations should be at least equal to my number of unknowns. But typically in real life, do you have that? Do you have the luxury of examples? No. So my dimensions are far higher, my number of examples are far lower. That is a famous paradigm in machine learning called curse of dimensionality. So how do I overcome the curse of dimensionality? Through dimensionality reduction techniques. If maximizing, preserving variance is important, I use PCA, principal component analysis. If maximizing the class separability is important, I use LDA, Fisher discriminant, etc. Linear discriminant analysis, QDA, etc. So there are methods in which I project my data into a different dimensions to reduce my number of features. There again, I can work with lesser number of features and good number of examples. So remember, curse of dimensionality is very, very important. Class bias is also a very important problem you need to deal with. So I would strongly recommend going to there is Medium. Get a student subscription for Medium. There are a lot of very good articles in data science. Towards Data Science is a very famous website where you will get a lot of knowledge. Analytics Vidya has a lot of information. There are a lot of very good YouTubes. In fact, Stanford University itself has a lot of available YouTube, the classes which they conducted as part of their undergrad and grad curriculum, available for free in YouTube. So just go through all this content. It's very useful. So any questions so far before we revise a quick recap? Any questions, please? Okay, let me quickly do a quick recap. You can again ask questions. So why we are doing this? Because we do not want to take decisions based on gut. We want to take database decisions. Why is important? So you know you have spent your time wisely. You have not wasted it, hopefully. I do hope that you close on with that thought process. What are the concepts we have learned? What? You have learned about intelligence. What is intelligence? It's an ability to learn from experience, solve problems, use knowledge to adapt to new situations. Likewise, learning is also learning from experience, blah, blah, blah. We learned about features. Features are attributes that differentiate a category. German Shepherd dog, Dalmatian, Greyhound, whatnot. And what is a class? Class is nothing but a category. And what is generalization? Ability to learn from my experience, my training data, and predict the test data. Not overfit, not memorize. And what is optimization? The process of finding decision variables by maximizing or minimizing my objective functions subject to constraints. And what is machine learning? Machine learning is an optimization problem. I'm trying to minimize my cost function, maximize class separability if classification is my problem, minimize within class variance. Again, if class separation is my problem, classification is my problem, subject to some constraints. So remember, machine learning is an optimization problem. The more you embrace optimization, the better you will be able to work through models rather than blindly calling a program and using it. The why is very, very important. So how? We work through the intuitive examples, the neighbor example, actor, policeman. We talked about nearest neighbor being a non-parametric classifier. You're not learning anything during training. You're just memorizing the data. And what is the tools using which you increase or decrease the complexity? One very important metric is distance, which is a hyperparameter. K is also a hyperparameter. We learned that less K is more complex, more prone to noise, more brittle. More K, more smoother decision boundaries. Right? Increase the complexity KNA of KNN using, actually it is not increasing, decreasing the complexity. Let me just correct it, guys, sorry. Okay, increasing hyperparameter makes the model less complex and more generalized. And we talked about pros and cons. Training time is very fast, scoring time is very poor. So near runtime where scoring parameters, the time in which the model response is key, I cannot use KNN. And as I said, there are KD trees, etc., where a lot of research is going on. So any questions and answers? Any questions, please? I'll give the answers. Please ask questions. Now, honestly, considering your profile, your first year, second year students, I was really amazed at the kind of participations you guys had, the questions you asked, and I forgot the name of Shreyansh. Yes, Shreyansh. Very nice questions, very good questions. And the thought process that came into your class is really amazing. Amazing. Keep thinking, keep learning. Go through YouTube videos, go through Coursera courses as students. You can join free. Andrew Next courses are out there in Coursera. Get your college certificate that you're a student. You will get a free course. You can learn deep learning. You can learn convolution neural networks. You can learn RNNs, recurrent neural networks. You can learn GANs. You can learn a lot of technology for free, because a lot of institutes are actually sharing that content for free, so that machine learning can be utilized for greater common good. Okay, keep learning, guys. Again, I'm here not to sound as if I'm from Mars, etc. I'm a student like you. I'm still learning. But whatever I learned, I found that this was the key differentiator. A lot of people do courses from elsewhere, in Sophie, etc., but they don't understand the basic definition of machine learning. They don't correlate optimization to machine learning. People have done courses, they say they have written models, and even the so-called interviewers, panels, companies who are recruiting are more carried away by the names of the models. Do I really need a machine learning if I'm just tracking a trend? No. Why should I use something because it is fuzzy looking, sounding very good? No. It all depends on the nature of my business problem I'm attempting to solve, the kind of data I have. Garbage in, garbage out, that is what we use in our programs, right? So your quality of data determines the quality of your model. There is nothing special you can do. There are a lot of optimized models out there. But what is the biggest takeaway for you as potential AI scientists is your ability to work through data, clean the data, impute the data, work through class imbalance problems, and do feature engineering, design features, and then feed it into the model. People who top Kaggle competitions are those who do all this. Blindly using the models will take you nowhere. Understanding the nature of data, working with the data, cleaning the data, working on feature engineering is which differentiates you from the rest. Okay, any questions? Please.
No, sir.
And you can, if you have any further questions, you can just pass on to Jatinder, and I'd be more than glad to look through and answer. It's from the questions is what I get a kick that I'm learning more, because I tend to do more research to come back and find your answers. Really nice questions from Shreyans. Really very good thought process from you guys. Keep asking questions, and because I love teaching, because that will make me always be on my toes to improvise myself, to learn myself better, so that I don't give you some wrong information, right? That's very, very important.
Thank you for the brilliant session, Mr. Samir. So it's time to wind up this session. Audience, the survey link is in the chat box. Please fill the form before you leave. I appreciate the efforts taken by Department of Computer Science, Engineering, AI, ML, and Cybersecurity, and Futurance Technologies for organizing the Industry Connect program for our students to make sure that they have proper industrial exposure. We are grateful to our guest of honor, Mr. Samir Vittala, for interacting with our students. I thank Dr. V. Vivek, the head of the Department of Computer Science Engineering in Artificial Intelligence and Machine Learning and Cybersecurity, for eminently spearheading the departmental activities. I also thank our team of faculty members for guiding our students in academic and co-curricular activities. Dear students, we are glad that you are making use of these opportunities. Thanks for participating. We will meet the same time next Saturday with another wonderful session of Industry Connect. Good night.
Thank you very much. Thanks a lot.
Thank you, sir.
Thank you. Thank you, sir.